This video is for 7.5 solving nonlinear systems. So we're going to be using a combination of substitution to solve systems of two equations where one of your equations is linear, so it's going to be a line of some sort, and the other one is probably going to be quadratic. So we're going to have to use a combination of substitution and maybe some factoring in order to solve for these values. So we're going to have something that looks like this. You're going to have a graph, and you're going to have some kind of linear function, so a line going this way, and then a quadratic function. So remember, your quadratic function is a parabola. And it's going to look something like that. So what we're looking for are points of intersection. It's very similar to what we were doing with the systems in two variables. So you have a point of intersection here and a point of intersection there. So you can solve it using graphing if you want to, but then you have to trace and whatever. But what we're going to do is solve them algebraically. And that's not going to take too much time. So we have our first example, y equals x squared minus 3x, and y is equal to 3x. So in the same way that we were able to substitute, one equation into the other, that's what we're going to do here. So because they're both equal to y, I'm actually going to take this 3x here and plug it into that y there, so that we can have an equation with just one variable in it. So now I'm going to have 3x is equal to x squared minus 3x. So I'm going to go ahead and combine my like terms. So I'm going to move this 3x over here and factor. So if I move this 3x minus 3x, I'm actually going to be left with the 0 is equal to x squared minus 6x, which is fine. If this, this should look like when we were solving quadratic functions, and we had to factor and set each factor equal to 0, which is exactly what we're going to do. Here I'm going to take out the GCF. I see here that my common factor is going to be x. So if I take out an x, I'm left with x minus 6 is equal to 0. Now I can just set each one of those equal to 0. So I can say x is equal to 0 and x minus 6 is equal to 0. And then just solve each one. From here, I get x equals 0. And from here, you're going to add 6 to each side. So x is equal to positive 6. Now, all I've found are the x values for the intersections. I still need to find the y's. So in order to find the y's, I'm going to plug these back into the original equations over here and solve for them. It doesn't matter which one you plug it into, because it should work either way. So let's go ahead and do that. I'm going to use this one because it'll be easier. So I have y is equal to 3x. I'm going to solve the first one. Y is equal to 3 times 0. Y is equal to 0. So for this point here, y is equal to 0. And then I'm going to do it again. Y is equal to 3x. Y is equal to 3 times 6. Y is equal to 18. Okay, so I have y equals 18. Y equals 0. So for x equals 6, y is going to be equal to 18. Just like when we did the solving systems, your solution is always a point. So you want to write them as points. This is going to be the point 0, 0, and this is going to be the point 6, 18. Okay, and that is your solution. That is the points of intersection for these two graphs. I have one more example for you. Okay, these are already solved for y, so we can just plug one side into the other one and do the same thing. We're going to do substitution, factor, and then solve. So I have 2x minus 2 is equal to x squared minus x minus 6. So I'm going to go ahead and combine like terms. You want to move everything over to one side so that it's set equal to 0. So it doesn't matter which side you move it to. I'm going to do plus 2 here, plus 2. 2x is equal to x squared minus x minus 4. Divide everything by 2. Sorry, that is incorrect. I don't want to divide here. I want to actually move this over to the other side, so I'm going to subtract it. Minus 2x, minus 2x here. So now I'm going to get 0 on the left-hand side and x squared negative x minus 2x is negative 3x minus 4. So now we can go ahead and factor. Remember, when you factor, you can do it by grouping or bottoms up or guess and check. You're looking for the product of a times c. So just a refresher, 1 times negative 4 is negative 4, whose factors sum to b, which is negative 3. So those are going to be negative 4 times positive 1. Negative 4 plus 1 is negative 3. That's what we're looking for. So we have x minus 4 times x plus 1 is equal to 0. And we can set each factor equal to 0 and solve for it. Okay, so here you would add 4 to each side. X is equal to positive 4. Subtract 1 on each side for this one. X is equal to negative 1. So we have our x's here. We need to find our y's that correspond to each one. In order to do that, we're going to plug these into one of the original equations. I'm going to use this one because it's easier. So we have y is equal to 2x minus 2. Y is equal to 2 times 4 minus 2. 8 minus 2 is equal to 6. Okay, so when x is 4, y is equal to 6. We'll do it again for the second one. Y is equal to 2 times negative 1 minus 2. It's negative 2 minus 2. Y is equal to negative 4. So when x is equal to negative 1, y is negative 4. So our points of intersection are the point 4, 6, and negative 1, negative 4. Check. Yep, okay. And that's it. Here's your solution. And that's all we're doing. If you have any questions, let me know. Shoot me a remind or ask me tomorrow in class.